Welcome to Summarize Science. Have you ever wanted to capture a real-world place and turn it into a 3D model you can explore on your computer? Traditionally, this process, called 3D reconstruction, is incredibly slow and data-hungry, often requiring thousands of photos or specialized equipment. But a new AI model called ReSplat, detailed in this paper, is making this process incredibly fast and efficient. It uses a technique called 3D Gaussian Splatting, which you can think of as building a scene out of millions of tiny, colorful, semi-transparent blobs. The real magic of ReSplat is in how it learns and improves. Unlike other methods that try to get everything right in one single, complex step, ReSplat works more like an artist sketching and refining their work. As you can see in this diagram, it starts by making a quick, initial guess of the 3D scene from just a handful of images. This first guess is very compact, using 16 times fewer of those Gaussian blobs than previous methods, which is key to its speed. Then comes the clever part, the feedback loop. The AI renders its own 3D model back into 2D images from the original camera angles and compares them to the real photos it was given. The difference between the two, called the rendering error, tells the AI exactly where it went wrong. It uses this error as a guide to adjust the position, color, and shape of its 3D blobs. It repeats this refinement process a few times, and with each loop, the 3D model gets significantly more accurate. The results are pretty staggering. Let's look at this comparison table. On a challenging dataset, ReSplat achieves a much higher quality score, measured here as PSNR, than both previous feed-forward models and even the standard optimization method, 3DGS. And look at the speed. It can generate a scene in under a second, which is over 100 times faster than the 70 seconds required by 3DGS. The visual results speak for themselves. The images rendered by ReSplat are sharper and more detailed. But perhaps the most impressive feature is its ability to generalize. Many AI models struggle when they encounter data that looks different from what they were trained on. As these graphs show, when the ReSplat model, trained on one dataset, is tested on a completely different one, its performance improves dramatically with each refinement step. It also handles different image resolutions it has never seen before with incredible robustness. This is because the feedback loop allows it to adapt to new scenes at test time, essentially learning on the fly. So let's recap the key breakthroughs. ReSplat introduces a recurrent, iterative process that refines a 3D scene by learning from its own rendering errors. It works with a highly compact representation, using 16 times fewer Gaussians to be extremely efficient. This leads to state-of-the-art quality at speeds over 100 times faster than conventional methods. The implications for the future are huge. This technology could dramatically speed up the creation of assets for video games, virtual reality experiences, and architectural visualization. Imagine being able to create a high-quality 3D scan of a room with just a few snaps from your phone. Thanks for watching Summarize Science.